Hey everyone, welcome back. This is Vivek Bharata. Imagine you're juggling a complex backend where microservices are built in different languages. Need to communicate with lightning speed. Now, wouldn't it be a game changer if you could get Node.js to talk to a Go language based service directly? In today's video, we are diving into how gRPC does that, making it easy to have your services speak the same language even when they are written in different ones. Now, we'll be taking an example where we have an order service which is written in Node.js and we have mailer service which is written in Go language. Before diving into this actual implementation detail, let's start from the very basics. So what exactly is an RPC and how gRPC extends on top of RPC? So to begin with, let's start with a very basic example. Imagine there is a one single machine or a monolithic application. Inside we have two modules, order module and mailer module. So whenever the order has been confirmed, we need to send a mail notification to the customer, right? So in that case, order module will simply call some function of the mailer module like send email after confirmation. So as soon as order has been confirmed, order module simply calls a local function of a mailer module to just trigger an email. So in this case, it's purely a simple local function is being called from the order module to a mailer module, and mailer module, that specific function will just trigger an email. Now imagine these modules has been converted into a proper microservices and both are deployed in different machines. In that case, you can't just directly call the local function of the mailer module to send an email. That's where RPC comes into a picture, that is remote procedure call. So what is the concept behind a remote procedure call? RPC is a general protocol that allows a program to execute a procedure on a remote server as if it were local, abstracting away the complexities of network communication. As part of the normal RPC, data serialization were often used as text-based formats like JSON or XML, which can be slow and produce larger payloads. And moving on to the transfer protocol, usually RPC uses HTTP 1.1, which has more latency. And RPC can work with various languages, but may require additional effort for compatibility, especially when using different data formats. Like let's say one order service is using XML or mailer module is using JSON. So it's kind of a tricky to have that things in place. It adds an additional effort for compatibility. Now as you can see here, we have some problems already. At the data serialization, it does support JSON and XML, which is basically a higher payload. And also RPC uses HTTP 1.1, which has more latency when compared to HTTP 2 version. And there's a challenge in communication between different languages. Though it is supported, but we need more effort to put in. So considering these problems, Google actually came up with a new modernized RPC framework, which is optimized for high performance inter-service communication, particularly in microservices. gRPC uses protocol buffers. In short term, it's called protobuf, a compact binary format that is faster and reduces payload size, enabling efficient communication. Whereas in JSON, we need to exclusively pass the full key and value across the whole network. And gRPC uses HTTP2, which supports multiplexing and bidirectional communication, offering low latency and better connection efficiency. In a simple terms, HTTP 1.1, for every request, a new TCP connection will be open. But whereas in HTTP 2, the main advantage is with one TCP connection, we can actually trigger multiple requests in a same TCP connection, and also supports bidirectional communication. And also gRPC natively supports 4 different types like unidirectional, bidirectional, client or server streaming. So which makes it versatile for real-time applications. And there is a great flexibility for language interoperability, as in gRPC has wide language support, generating code from protobuf definitions in multiple languages, making it easier to maintain cross-platform compatibility. I have a proper example where one service will be in Node.js and the other service in Go language, and I'll show you how to generate code for protobuf definitions for Go service. Till this point, if you found this helpful, make sure you hit that like button. Moving on to actual practical example, let's say we have an order service which is written in Node.js and mailer service which is written in Go. So once order has been confirmed, order service will trigger a proto request, and once the mailer service has consumed that request and sent an email, it will send the response as proto response back to the order service which is written in Node.js but mailer service written in Go. So the common element is mailer.proto. So this is a proto definition where you will mention what is the service name, what is the RPC function call, and also the request and response types. And this will be same for both order service and also for mailer service. And as you can see here, on the mailer service there is a gRPC server, and on the node service this is gRPC stub where it is also called as gRPC client, where in this use case, order service acts as a client or gRPC stub, where it will call a function of the gRPC server. And only in this case, order service can also act as a gRPC server for the same mailer service, or if we have some other microservice over here, where this microservice acts as a client and this order service can also act as a server, and this order service can maintain a different proto file, and in that we can mention all the different functions and the response and request param objects. Now that we have covered the theoretical part, let's jump into the practical example. So I already created two folders, order and mailer service. I'll just start with the order. We'll start with the main proto file, that is here I define it as mailer.proto, and here at the first line we mention the proto version, that is the latest of proto 3, and the package is mailer. Again, this is a similar namespace grouping type of definition, so you would maintain the package as mailer. And option go package, as we will maintain the same proto file, this specific line is for the Go package when you want to generate the proto-buff code. I'll just cover this line later. Then if you can see here, I defined one block that is as service, and the service name I define it as mailer service. And inside, first definition is RPC remote procedure call and that specific function name, that is send order confirmation. And order request is like the request payload, and the response payload is order response. And also, let's say if you want to get the list of emails like the last 10, so we can actually create another RPC function like last 10 emails just to retrieve. So we can pass email type, we can pass as, so that we can pass as email request, and returns email response. We can also make it a bit more easy, like email list request and email list response, and you can clearly mention the specific message types also. But in our case, it's only one RPC call for now, so that is send order confirmation. And also, if you can see here, order request also we clearly mentioned as a one message unit, and inside we have two fields. One is order ID of type string, and these 1 and 2 are called field tags, which plays a key role on transforming this whole order request payload into a proper protobuf serialization. And also similarly on the order response, success, which is boolean of field tag of 1, string message field tag of 2. So later also, let's say if you want to change the key, as long as we maintain the same field tag, there won't be any issue. I hope this is clear. So I'll just reiterate. First line is the syntax, and we mentioned the proto version. Package is to maintain as a similar namespace behavior, and also we can define multiple services. So here in this case, we define a mailer service, and in this mailer service, we have one RPC function that is send order confirmation, and the request payload is order request, and we clearly mention here how the order request payload would be, and also for the order response. That's it. Let's just open the order service.js, which acts as a gRPC client or a gRPC stub. And you can see here we are using the JavaScript libraries from the gRPC and the proto loader, and we have proto path, that is mailer.proto, the one what we have defined and covered. And later we have this library function proto loader load sync and the whole package definition, and we are actually getting a mailer proto object with this helper function. That's it. Once it is there, I'm creating a mailer client, also mailer stub, new mailer proto, mailer service 50,051, gRPC server assuming which is running at 50,051, which is a mailer service definition. I'll just cover it very soon. So this is a mailer step, and we have this function placeholder, maybe assuming this as one of the API requests which is triggered from the client or whatever the example is. This is an entry, and I'm just simulating the same. So placeholder 1234 customer@example.com. So inside function of place order definition, as you can see, we are just constructed the request as order ID and email, which is similar to over here, order ID and email, okay, as an object. So with this mailer stub, as there is a function send order confirmation, I'm just using that function. That's it. So the first argument is the whole request object that is in alignment with the order request structure, and a callback if there is an error in calling a remote procedure call. And if everything works, we are just printing the response over here. That's it. So now I just call order service, which will fail because there is no mailer service running. As you can see, error connection refused. And it is trying to reach a server which is listening at 50,051. Save this. I hope till this part it is clear. Now let's move on to mailer code. So there is a main.go, which is a main actual core server. I am not sure how many people are familiar with Go language, but for this example of gRPC I'm demonstrating, so you can just try to follow along. And I also have a JavaScript implementation of the same mailer service, but to actually demonstrate an interoperability where a Node.js service of order service can actually call a gRPC remote procedure call mailer service, which is written in Go language. So but still I'll just cover the mailer service later at the end, but let's start with the main.go, which is an entry point in the Go language. And there are some imports and all, and if you can see here there is a pb mailer, and also if you can see now it's not able to resolve it, but because I deleted this module, but I'll regenerate the code now. But if you can see here at line 18 I have this send order confirmation. This is actually the remote function definition. When the order service, this function is called send order confirmation, you can assume that in a way that this specific block will be executed. Simple, that's it. How exactly it will be executed? Based on the generated code from the mailer.proto file, main.go, this specific pb will get all the helper functions and the definitions for it in a way that we can create a definition of that function and we can attach that to the one of our gRPC server. That's it. So to begin with, main function is an entry point, and over here we are listening at 50,051, and we are creating a gRPC instance of the server, and we are registering the mailer service over here. Register mailer service server gRPC server, and the server object is actually the struct, which is again coming from the generated code. Just stay along with me, but my main intention is order service, this send mailer stuff, send order confirmation. You can assume that this function execution will call this specific block. That's it. So you can correlate in that way. Now it's a fun time. As you can see here, ignore this node modules and mailer service.js file and also the package.json files for now. So now first I will generate the code. If you can see here, this is the command proto -go out dot, which basically telling that we'll generate the code over in the root mailer folder, and also go gRPC out. This command is for to generate the protobuf definitions where it transforms the serialization, deserialization logic and all, and this go gRPC out will give us all the server definitions and the client definitions. With this simple CLI command, if I can refresh, it will generate a folder mailer, and if you can see here there are two files generated automatically. So mailer.pb.go, this is a fully generated code, and it is importing some of the helper modules and all, and it has all the functions and helper functions based on this mailer.proto definition. And also we have mailer gRPC pb.go. This is also a generated code where it has interfaces and function definitions for the mailer service, and these interfaces and functions are being used inside the main.go. Like for example, if you see pb.register mailer service server, and if I just click it here, it is going inside this auto generated code. So that's how it will be used. In this example, mailer service is written in Go language, right? But it can be Java, Python, anything. gRPC supports well-known languages. So irrespective of the different language, if we have just the proto, we can generate the protobuf serialized and deserialized and all the helper functions file, and also the client and server file also. I hope till now it is clear. As we have generated the files, we can just run main.go. I guess you can see now. So mailer service is running on port 50,051. Now we'll run order service. So now the magic happens. If you see here, mailer service response success true, message email sent successfully, right? And also if you see here, as we have added logs in the main.go, I'll just, so over here, received order confirmation request for order ID and email. You can see here, received order confirmation request for order ID 1234 and email customer@example.com. Sending confirmation email to so and so for order ID. So just to reiterate again, and also to basically mind map the whole thing. So in the order service, which is a separate microservice, but as we are constructing and we are getting an object that is a mailer stub, which you can correlate as main.go, like mailer instances object, and inside send order confirmation. So we are calling a remote function send order confirmation, and that would be this one. That's it. And also let's say if email sent successfully and also add tada, right? Now I can restart, go run main.go. Now I can restart this server, and if I can just start node.service.js again, now in the response I'll get tada. That's it. I hope this is clear. If Go is a bit tricky, I'll just go through the JavaScript version of it. So mailerservice.js, this will be more or less similar. So we have this helper libraries over here, mailer.proto, the same file, package definition, and we'll get the mailer proto instance. And we have this send order confirmation, the gRPC server's function definition. Okay, and we have a main function where we are creating a gRPC server instance, and also we are adding a mailer service definition. If you see here, mailer proto mailer service dot service. In the mailer proto, we are calling this mailer service, and in the mailer dot proto file, we have this mailer service definition. So that's how you can refer to mailer service dot service, and which is binding to 50,051. I can just give a walkthrough. So instead of running in Go, now I'll just run in uh, Node.js. Okay. So it is running. Now if I call node order service, yeah, so sending confirmation email, so and so, and email sent successfully. We also have tada, I think, in the JavaScript version of the gRPC server over here. That's it. I hope this is clear. To sum it up, with gRPC, language differences fade away. Node.js can call Go service as easily as if it were a local service. No extra wrappers, no complex setup. This mailer.proto file takes care of compatibility issues, and gRPC handles that REST under the hood. That is gRPC, the protocol that is faster than REST, simpler than SOAP, and works beautifully across different languages. If you are building microservices and want to break language barrier without sacrificing speed, give gRPC a shot. If you love this breakdown, make sure you hit that like button and subscribe for more on the backend engineering, microservices, and beyond. Thank you so much for watching, and I'll see you in the next one.